For number 4, a cylindrical barrel with a diameter of 2 feet contains collected rainwater. The rate of change of the height h of the water in the barrel is with respect to time is modeled by dH dt equals negative 1/10 square root of h, where h is measured in feet and t is measured in seconds. So the unit will be feet over seconds. For A, we need to find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. That means h equals 4 feet. Rate of change of the volume is dv dt, and we can take the derivative of v equals pi r squared h. And since it is a cylindrical barrel, the radius never changes, so you can just treat r squared as constants. So that is pi r squared dh dt. When h equals 4, h equals 4 and radius is always 1 because the diameter is 2 feet. So radius is 1. So dH dt will be, and dH dt when h is 4 is negative 1/10 times square root of 4, which is negative 1/5. So you can just plug that into this equation, which states dv dt equals pi 1 squared times negative 1/5, which equals negative pi over 5 feet per second. And for B, height of the water is 3 feet, and we have to determine if the rate of change of the height of the water with respect to time is increasing or decreasing. We need to find the second derivative of the height, which is negative 1/20 times h to the negative 1/2 power, which equals negative 1/20 times 1 over square root of 3, because the height is 3 feet. So that is negative square root of 3 over 60 feet per second squared. And this is smaller than 0. So we can say that when h equals 3, the rate of change of the height of the water with respect to time is decreasing, because d squared h over dt squared evaluated at h equals 3 is negative, meaning that dH dt is decreasing, and dH dt is the rate of change of the height of the water. For C, we're given that when t equals 0, the height of the water is 5 feet. We have to use the separation of variables to find an expression for h in terms of t. Since dH dt is negative 1/10 times square root of h, we can separate it by dividing h. So we get 1 over square root of h dh equals negative 1/10 dt, and we can take the antiderivative on both sides. So that is 2 square root of h equals negative 1/10 plus c, and h equals 5 when t equals 0, so we can plug that in to get c, and c equals 2 square root of 5. And if you simplify this equation, it becomes h equals negative 1 over 400 t squared plus 5. Thank you. Oh, and I found a mistake right here. This is not dH dt. This is integral of 1 over square root of h dh. Thank you.